So we're going to continue with the ambiguous case. This is also part of the law of sines. So if you notice, LOS stands for law of sines. In this case, you're given two sides and an angle. The angle and the sides have to be given so that one of the sides is opposite the angle that's given. For example, here, the B and the beta, they're opposite of each other, which is okay. I could have also been given alpha and A, and that would have worked. But if I was given gamma, that wouldn't have worked because I was only given A and B, not C. So the ambiguous case, the reason why it's called ambiguous is because it has multiple sides. Every other case, you are going to have one triangle. But in the ambiguous case, we could be given one triangle, no triangles, or two triangles. So it's pretty ambiguous. So we have to go over some of the information so you could tell which case it's actually given to us. The other thing is that some of these are going to be a little bit longer to solve and some are going to be really quick. But it's really going to be a little bit of a pain in the butt, and that's why, if you look at it, spelled backwards, so that's what it says. So if you're looking at, let's say, for instance, this, B is the angle B, and the opposite is the side B, and the adjacent side is A. So I made this here in GeoGebra so that it could sort of explain what we're doing here. So this is the third side. We're going to solve this triangle. This is the third side that we would need to know. We don't know it. And this angle over here, we do not know that either. We do not know the angle of A here. What we do know is that B is an acute angle, and it doesn't have to be. It could be an obtuse, and we'll talk about that in just a sec. So this one here is an acute angle, and the side adjacent is always going to be next to the given angle, and the side opposite is the one that's going to give us some information. So this side is never going to change. Well, neither of them are going to change. We just have to decide which one it is. But this one here, we're not even going to look at. That's the one we're going to compare it to. So that's 7, and this is the angle that is not going to change. But this side could have the opposite side could give us some more information on here. So one of the things that we know whether it will form a triangle is that the opposite side has to touch the third side. And so the shortest distance so that it touches the third side, if you look at it, it's when we have the altitude or the height. We're going to call it H for height on there. And what it does is it forms a right angle with the third side. This side here is the shortest distance between the vertex and the third side. So if the opposite side is equivalent to the height, then we're good to go. It's a right triangle because it forms a right angle. And then we're back to 6-3, which is SOHCAHTOA. And you could solve the whole triangle, all the angles, all the sides by doing opposite over hypotenuse, opposite over adjacent, all those on there. Now, what happens if it's not? And that's where it is. So I'm just going to put this here and say that that's the height, and the height is equivalent to 6.4. So that's the distance between C and the opposite. This forms a right angle. So looking at the opposite side, if it's equivalent to 6.4, then it's a right triangle and we can move on, solve it, easy. But what if it's shorter than 6.4? If it's shorter than 6.4, this is the shortest distance. That means that it's not going to touch the third side anywhere. So that one is going to be swinging back and forth. It's not going to touch it. And so therefore, there is no triangle. And if that's the case, then we are done with it and we don't need to do anything else. And so we just say no triangle. Now, what happens if the triangle, if the opposite side is going to be equivalent to 7? So what if it's the opposite side and the adjacent side are exactly going to be the same length? If that's the case, that means that I am going to, the only other place that I could put that is to put that close to 7. Well, you know what I mean. So that means that this side, the adjacent side, and the opposite side are going to be equivalent, and therefore it's an isosceles triangle, and I could solve it, and it is one triangle. So that is good. What happens if it's longer than 7? So what if the opposite side is longer than the adjacent side? Well, it's not going to form a triangle over here because it's not going to touch it. This is the angle that has to be included in our triangle, and it's not going to be included out here, so I can't swing over here. But this side over here, if it's bigger than 7, say 7.64, it's still going to form a triangle. It's not isosceles or anything like that. It's going to be an oblique triangle, and we could still solve it. It still solves one triangle because it's not going to touch anything else just on this side. And this side, we don't know the third side's length, so this could have been longer all the way over there. I just put it so that it would be right about there. So that's what we have on there. And so then so that's where this side could extend forever, and that's the triangle. It could be an oblique triangle, and that is not a problem there. Now, what happens if the opposite side is smaller than 7 but bigger than the height? So if it's smaller than 7 but bigger than the height, that means that we could choose anything on here. So if it's smaller than 7 and bigger than the height, that's going to touch the third side right over here. So see how this is 7 and this is 6.38? Then this one here is 6.63, and so it's going to touch the third side. Anything on here is going to touch the third side between 7 and 3.8. But if it also touches that side, let's say that I have 6.6 there, then the other side, I could also touch the other side at 6.6 as well. I could touch the other side, anything in between 6.38 and 7, and it'll touch it on this side as well. So it's going to form actually two triangles. This is the case where it forms two triangles. So if it's between 7 and 6.38, anything that falls in between here, it's going to be able to be done on the other side. And when it's in this side, it forms an obtuse triangle. So you see this here right there, that's an obtuse triangle. And when I move it to this side, it is going to form an acute triangle. So you have to solve the obtuse triangle and the acute triangle. So if we look back to what we were looking up here, that is the case. So here's the height. This is the opposite side. Here's that triangle. Without the height, this is the one that we're talking about. So this here is one obtuse triangle. And then the acute triangle is the whole entire triangle. And so if this was missing on there. And so that's what the two triangles are going to be. So if I look at this and let's say that the height was going to be 6.4. So let's say that the height of this triangle, hold on, let me see. The height of this one is 6.4. That means that you drop that down, and then this here is your h is 6.4. Let's answer these questions. So the adjacent side is always going to be 7. And these are the different cases for the side opposite. So if the side opposite is going to be 4 and it's an acute triangle, then we know that that the height on here, we're going to put down height is 6.4. We know that the height is bigger than this, so this one's going to be no triangle. And then just say no triangles. If the opposite side is 7 and this is 6.4, that means it's equivalent to the height. And so now we have one right triangle. If it's 7 and this is 6.8, that means that it's in between the 7 and the 6.8. This tells me that I have two triangles. One is going to be obtuse, and one of them is going to be acute. And you have to solve for both of them. And if I look at that and they're exactly the same, so the opposite side and the adjacent side is going to be exactly the same, then we have one isosceles triangle. And then if the opposite side is bigger than the adjacent side, it only forms one triangle on this side. So that is one triangle. And so that's what you have. Those are the different cases for if it was an acute triangle. Now let's go back and see what happens if it is an obtuse triangle. So an obtuse triangle, that means that the angle B is actually going to be bigger than 90, so it's going to look like this. And notice how you no longer could have the height because it's not going to form a right triangle there. The height is going to have to move outside, but we don't want to have anything to do with it outside. We want just to have it inside right now. And so I'm going to get rid of that. This is the side opposite of here. So if this is an obtuse triangle, what happens, and let's change that to 7 again. There we go. Oops. Okay, I'm gonna just keep it that there. 7.01, if I look at this, what happens if this side, if the opposite side is smaller than the adjacent side? Well, if it's smaller, there's no way it's going to reach the third side. So if the side is smaller than the adjacent side, there is no triangle because it can't reach it. What happens if it's exactly the same? If it's exactly the same, again, nothing. And so therefore it's not going to work there because it can't form a right triangle because it's going to be right on top of it. I mean, it's just not going to form a triangle, let alone right. So that means that anything, if I look at this, the opposite side has to be bigger than the adjacent side if the angle is obtuse. So if the angle that's given is obtuse, then the opposite side has to be bigger than the adjacent side. Otherwise, it's never going to form a triangle. So let's go back to what we had over here. And so if this one here, 7, and that's a 4, that's the opposite side, there is no triangle. Here again, still smaller, so therefore there is no triangle. It's still smaller, no triangle. If it's the same, it's no triangle. If it's bigger, then it's one triangle, and then we're done.